So in the last lesson, we talked about angle pairs. Now we're going to take that one step further. We're still going to be looking at angles, but now one of my favorite things, there's these, parallel lines cut by a transversal. Okay, so a couple things here. I want you to just kind of look at this diagram, and I'm going to read this, when two parallel lines are cut by a transversal, 8 special types of angles are created. Okay, the names and the properties are listed below. So let's just look at this diagram, and I want to point out a couple things. The first thing I want to point out is, these little symbols here, they kind of look like triangle symbols. These symbols here and here, when you see those triangles on a line, that's the parallel symbol. That's how you know, like if this was called line A and this was line B, you would know that these lines are for sure parallel. And one way that you'll see that written with geometry symbols is A is parallel to B. Okay, that's one thing that you'll see. A and B are parallel. That's that symbol for parallel. So A and B would be parallel. We know that. Now this goofy word transversal, if these are my two parallel lines, the word transversal is just like another line that goes through those two parallel lines. So again, parallel lines cut by a transversal. This would be considered my transversal right here. Okay, now again, notice there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 angles here in this diagram. Now I want to just kind of take some time here. Again, more vocab. You might have to refer back to this, but let's identify something called the alternate exterior angles. So again, here's 8 special angles. I'm going to write down for you guys which ones are alternate exterior. Now, one thing I want to just point out is when you have your parallel lines, there's, the interior. To me, the interior means the inside, right? So like angles 3, 4, 5, and 6. These are the interior. Well, then, therefore, the exterior would be referring to like 1, 2, 7, and 8. These are on the outside. So again, the interior and the exterior. So if I'm looking at alternate exterior angles, I know they're exterior, and the word alternate means that they're going to be on alternate sides of the transversal. So if I just tell you, hey, 1 and 8, angle 1 and angle 8 are considered alternate exterior. Well, then there's another pair too, right? 2 and 7. Angles 2 and angle 7 would also be considered alternate exterior, right? They're on alternate sides of the transversal line, and they're on the exterior, right? 2 and 7, 1 and 8. Those are alternate exterior. And the thing I want you to just make note of here is alternate exterior angles are always going to be congruent. That means they're the same, right? So 1 and 8 are going to be the same angle, and 2 and 7 are also going to be the same angle. Let's try alternate interior. Now we can probably go a little quicker, but alternate interior, well, that would be on the interior, like how about 3 and probably 6, right? 3 and 6 are called alternate interior. And the other pair, besides 3 and 6, would also be 4 and 5. Angle 4 and angle 5 are also called alternate interior. And the thing, too, that I want to make note of is that alternate interior angles are also congruent. They're congruent. So that means 3 and 6 have to have the same measure, and 4 and 5 also have to have the same measure, okay? Corresponding angles. There's a lot of corresponding. This is kind of the tricky one, but to me the word corresponding means like its match. Find its match, okay? And what do I mean by that? Every angle has a corresponding angle. So let's start with 1. Angle 1 has a corresponding angle. Angle 1, meaning it's basically the exact same angle. It looks the exact same, but it's in a different location. How about this? Angle 1 and angle 5. 1 and 5. It's like if I just moved 5, if I slid this angle up, it would land right on top of 1 and it would look the same. That's what I mean by corresponding. It just, if you slide it up, it would be right on top of it. So angle 1 and angle 5 are corresponding. Okay, how about 2? Angle 2 also has a corresponding angle. It would be 2 and 6. 2 and 6 are corresponding, right? How about angle 3? Angle 3 also has a corresponding angle. If I just slide this down, angle 3, it would slide on top of the 7, right? So 3 and 7 are corresponding, and then one more, it would be 4 and 8. Angle 4 and angle 8 are also corresponding. And again, notice congruent, congruent. Well, guess what? Corresponding angles are also going to be congruent. The last one, if you look, just kind of look, consecutive angles. Here's a lot of times too, they're called consecutive interior angles. And consecutive interior angles, like where are they? So if I'm looking at the interior, this was alternate interior. Consecutive kind of means like boom, boom, they're right next to each other and they're on the same side of the transversal. So 3 and 5, angle 3 and angle 5, those are called consecutive angles. And then 4 and 6, those are also called consecutive interior angles. Now notice, 3 and 5, they don't even look like they have the same measure. So we got to be careful here. 3 and 5 are not congruent. 4 and 6 are not congruent. But what we do know is that they have to add to 180. So this was like the big part of everything. I want you to be able to know what these angles are called, but then also, are they equal? Do they add to 180? So let's kind of go through this kind of quick here, where, a quick section like this. Find the measure of all 8 angles in the diagram below. Find the measure. Let's just write it down. Let's write down every single angle in this diagram. So here's kind of what I would say. Notice these are my parallel line symbols. So I have my parallel lines. I have a transversal. So I created a bunch of angles. Now here's kind of what I like to do. Remember from the last lesson, vertical angles. If this is 50, this vertical angle also has to be 50. Now, what else do you know in geometry is that, well, hey, remember, straight lines. If you have a straight line, it always adds to 180. So, again, think about always doing like, well, if that's 50, what would this have to be? Well, 180 minus 50 is 130. It's got to be, right? That's got to be 130. And then, hey, guess what? This also has a vertical angle. It would be 130. Now, how do we get the other set up here? Well, you could do this a couple different ways. Remember, how about this? Alternate interior angles. Remember, up here we learned that alternate interior angles are always going to be equal. So if this is 50, this has to be 50. And then guess what? You got vertical angles. I already know it's 130, 130. Okay, so notice all 8 angles. Boom, done. And again, it goes quick, like, this one here, well, 100 vertical angles. Straight lines always add up to 180, so then this must be 80. This must be 80. And then again, a couple different ways you can do this. Let's try a different one here. How about if I went to, well, how about alternate exterior angles? So again, alternate exterior. If this is 100, the alternate exterior would be way over here. That would also have to be 100. And then again, vertical angles 100, straight lines always add up to 180. Okay, so again, it works. So parallel lines and transversals are kind of neat, and it goes quick. How about this one? Notice here this symbol, given that L is parallel to M. So here's my 2 lines. They're telling me that, hey, these are parallel. That's important. So again, I might just put little triangles here, like, yep, those lines are parallel. What's the measure of every angle? So again, similar to these, but now notice like, there's something else is goofy here. So again, when you're doing this, I encourage you, like, well, if this is 60, the vertical angle is 60, right? Straight lines always add up to 180. So if this is 60, I'm thinking this has to be 120, another vertical angle of 120. Let's go down here. Let's say if this is 100, the vertical angle has to be 100. The other angle on the straight line, if this is 100, well, that's got to be 80. Vertical angles are 80. So now we're kind of like, well, now what do we do? And here's where you got to just keep thinking. Now remember, these are parallel lines. So I'm going to go up to this diagram. I'm going to do something a little different. How about corresponding angles? If this is 80, remember, corresponding would be like, well, the same angle up here, if I slid this 80-degree angle up, it would land right here. So its corresponding angle also has to be 80. This vertical angle is 80. And then other, 100, 100. We're almost there. We're getting there. How about, so again, parallel lines. Remember, these are called consecutive angles, and I know consecutive angles always add up to 180. So if that's 120, this would have to be 60. So then again, 120 kind of all unfolds itself. If I keep going, 120, 120, 60, 60, vertical angle. Now here's the last part here that I want you to make note of. What shape is this right here? This would be a triangle. And triangles always add up to 180 degrees. So if I have 80 here and I have 60 here, that's 140. I would need 40 more degrees to get me to 180. Okay, so triangles always have to add up to 180. And now again, vertical angles, right? 40, 40. Kind of think about vertical angles. And straight lines are 180, so this would be 140 and 140. So kind of a neat little question there with diagram, like fill out everything, okay? Now here's kind of what I want to do down here. And you know, I just want us to, I'll set them all up and then I'll show my other sheet here just to save some time. But let's just kind of take a look, and I'm just going to, you know, maybe start with this one. You know, the question is, what's the value of x, okay? And you know, just every diagram is a little bit different. You have to know how to set up these equations. So again, you ask yourself, like, well, are they equal? Do they add to 180? What are they called? And I'm going to start here. It helps if you know what they're called. Like if I look here, you know, this 70-degree angle and this represented by 3x minus 20. Those are called corresponding angles, and I know that corresponding angles have to be equal. So if they are equal, let's set them equal. So set 3x minus 20 equal to 70, and that would be pretty easy to solve. I'll show you the setup in a second. Now I'm going to go back to this one. This one's a little goofy. Now, again, I like to get in the habit, if you're not sure, like, what is this? Why is there like an interior angle and then an exterior angle? And again, it just kind of looks weird. But what I do is, if I like to just label the diagram as much as I can. Like, I know this is 110. I'm always going to go to that vertical angle, and I would just put a 110 right here. So now this helps me because when I look at these two angles right here, I know what those two angles are called. Those are those consecutive angles. And I know that consecutive angles have to add up to 180. This plus this has to equal 180, right? So this x plus 20 plus another 110 has to add up to 180. Notice I didn't set them equal to each other because they're not equal. These angles are not the same. They add to 180. These ones were equal. Now again, let's just kind of keep looking here. This diagram looks a little bit different too, but here's my parallel lines. I see a 15x here. I see a 12x plus 30 here. Are those called anything special? And you could ask yourself, well, I think they're alternate interior. These are alternate interior angles. And if you look at the front of this notes again, alternate interior angles are equal. So we can set 12x plus 30 equal to 15x. And then again, just solve that equation. Now again, one more here. Well, what do you think we would do with this one? Let's try to do this one all in one step. These are consecutive angles. Are consecutive angles equal? No, these are not equal. Well, if they're not equal, my guess is they add to 180. Now, instead of writing it all out, let's just add these together in our head. 17x plus 6x, that would be 23x's when I add them together. How about a negative 6 plus a 2? A negative 6 plus a 2 would just be negative 4, right? So when I take this, I get 23x minus 4. I know that 23x's minus 4 has to add up to 180. And again, I'll just kind of switch on you here just for a time saver because we know how to solve equations. This isn't the hard part. This is the easy algebra part where, again, what's the value of x? You could see x is 50 in this one, x is 30 in this one, x was 10 in this one, and then x was 8 in this one. So again, just kind of solving them using parallel lines, okay? The last question here, I want to walk you through this one, and then we'll be good. The question, notice here, just says, which two lines are parallel? Explain how a certain pair of angles proves your answer. You know, use vocab words. So something a little different here. Now notice, like, hey, there's A, B, C, D. There looks like there's 4 lines. And the question is, which 2 lines are parallel? You know, and how do we know? So again, if you're looking at this diagram, here's what I would do. And again, let's just start labeling everything. And I'm always going to fall back on those vertical angles. So what I would do is 70 and 70. And then let's write down the other ones too. Because they have to add to 180. Remember, straight lines are 180. So if this is 70, this would be 110, and then its vertical angle would be 110. Let's just keep doing this. Now, if this is 109, this would be 109, and then subtract from 180 to get 71, and 71. Okay, keep going. How about the next one? 110, vertical angle 110, and then, well, it'd have to be 70 and 70. It'd have to be. And now the last one, 72 and 72. And then how about the other one would be subtract that from 180 to get, I believe it's 108 and 108. So that's kind of like, now which two lines are parallel? Well, what do you think? Which two lines are parallel? Are they all parallel? They're not. And again, how do we answer this? Is that go back to like, well, lines are parallel when, are the corresponding angles equal? Are the alternate interior angles equal? Are the alternate exterior angles equal? So let's just kind of take a look. If I add up 109 and 70 right here, that gives me 179. So A and B are for sure not parallel. They're not. And again, you could look like they're close to being parallel, but we know that they're not. So one thing I want to show you, I'm just going to circle. Notice like, hey, 110, 110, 70, and 70. Notice over here I have the same 110, 110, 70, and 70. Because all those angles are the same, my guess is A and C have to be parallel. And I just want to kind of show you, like, yeah, A and C are parallel. Notice that symbol. A is parallel to C because, and again, I wrote down everything here because I know that in these two sets of diagrams, the corresponding angles are equal. The alternate interior angles are equal. The alternate exterior angles are equal. And the consecutive angles in these two diagrams, they do add to 180. So that's how you know, it's how you know for sure that A and C have to be parallel and none of those other lines would be parallel. So again, parallel lines and transversals, good luck with this one.